When a critical industrial facility suddenly goes dark, the assembly lines stop and the revenue clock freezes. Highly trained repair crews mobilize almost immediately. They pack their gear and race to the site, ready to tackle a major mechanical failure. Upon arrival, they hit a wall. They have the skill to fix the problem, but no one has a trusted record detailing exactly which component triggered the outage. Every minute spent identifying the failure is a minute of lost production. The client bleeds money while the response team stands by, unable to start work. The costliest failures in critical infrastructure are failures of institutional memory long before they are failures of labor. George Samouhos, the founder of Metronos, faced this during a factory transformer failure. His team knew they could mobilize, but they didn't know which transformer had failed or which crane to bring. The choice was stark: dispatch a $30,000 crane with only a 1 in 3 chance of being right, or lose more time while the facility stayed dark. This pattern repeats everywhere. Capable people arrive under pressure and lose hours reconstructing what should already be known. Before a truck leaves the yard, the team needs the gate code, the physical access point, the specialty tools required, and the approved service record. Highly capable experts often spend their shift relearning the site and retracing system relationships. They deserve the context required to act with the precision of a surgeon. Metronos was built from 30 years of field operations, not from a venture capital brainstorm. Traditional asset software treats a transformer as a disconnected database row. In the field, it is a live node defined by upstream and downstream switchgear. A true record includes service history, engineering constraints, and the liability attached to every decision. Software designed for procurement checklists prioritizes the dashboard. However, the technician carrying operational liability in the field requires the truth fast enough to make the next move. In critical infrastructure, bad data is worse than no data. An error in an asset record does not manifest as a typo on a screen. It shows up when a system is energized, when the wrong part is ordered, or when a technician arrives unprepared for the risk. Organizations often fall back on reactive maintenance when they do not understand what they own. They operate by interruption because the memory of the asset is fragmented. Unlocking the intelligence trapped inside these facilities requires earning trust by showing up when it matters and doing the physical work correctly. What the industry calls a reactive operations model is frequently an information failure in disguise. On a macroeconomic scale, the built environment is entering a period of significant evolution. Serious owners and insurers are beginning to reprice assets based on the concept of verified digital memory. A facility running on fragmented tribal knowledge carries a different risk profile than one with a trusted record of its system relationships. A trusted digital record makes a facility more operable, more financeable, and more valuable to an acquirer. Verified asset intelligence is now a core piece of critical infrastructure. It provides the security that tribal knowledge cannot. Many assume that the primary purpose of AI is to automate judgment and replace skilled human labor. The physical world requires experts, but experts act more effectively when they have total context at the moment of action. Metronos is more than a CMMS, or computerized maintenance management system. It is the operating memory for the built environment, born from the real-world cost of not knowing. In critical infrastructure, artificial intelligence proves its value by providing experts with the context they need in the field. Metronos is the space where AI actually means asset intelligence.